In this video, we look at the important terms associated with friction. The first one being the coefficient of friction. In our previous videos, we saw that how a fridge resists your push and holds to the ground, but when the force is just enough, it starts to move. In friction, a lot depends on the contacting surfaces. For this purpose, we have a term called coefficient of friction. We know that when you apply some force on the fridge, there will be a tangential frictional force at the contact surface, and there will be a normal reaction at the point of contact between the surfaces due to weight. According to Coulomb's law of dry friction, the magnitude of the limiting static friction is proportional to the normal reaction between the two sliding surfaces. That is, Fs max is proportional to En. If we add a proportionality constant mu, it will be Fs max is equal to mu s times En. Mu s is called the coefficient of static friction. It is a constant which is decided on the nature of both contacting surfaces. Similar to this, when we are moving the object like fridge again, there will be kinetic friction. There will be a normal reaction between the two surfaces. This relation is also linear, which means Fk is also proportional to En. If we add a proportionality constant mu k, it will be Fk is equal to mu k times En. Mu k is called the coefficient of kinetic friction. So, both the coefficients gives us an idea of how one object slides on the other. If the value of coefficient of friction is 0, then there is no friction between the surfaces. This is practically impossible as all the contacting surfaces have some friction. To give an idea of the values of static friction, if we have a wood on wood, then the value of mu s is around 0.2 to 0.5, and if we have a stone on stone, mu s value will be around 0.4 to 0.7. This is how the value of mu s and mu k will be helpful while solving problems on friction. The next concept we learn is the angle of friction. Any body under friction will have a tangential force at the point of contact and the normal reaction to the weight of the body. As these two forces occur in every frictional problem, it is better to consider the resultant of these two and know about the object's behavior. We consider the angle between the normal reaction and the resultant to be phi. Now, to understand this angle of friction, let us consider few different cases. Case 1. If you don't apply any force on the object, there will be no frictional force at the plane of contact. As F is 0, the resultant R will be equal to normal reaction. Let us move to case 2. If you apply some force on the object, there will be an opposing tangential force at the plane of contact. If applied force is P1, the friction will be F1. The angle phi will also increase according to these forces. When you apply enough force, you will reach the point of impending motion. At this point, we know that the limiting static friction is at maximum. So, the angle phi will also be maximum at this point. This angle is known as the angle of static friction. When you consider the tan of the angle phi, tan phi is equal to Fs max divided by N. So, how can we define the angle of static friction? It is the inclination of the resultant of force at the point of impending motion. But what does this angle of friction mean to us? What does it imply? It is the angle after which the object will start to move. And how will this angle change? It changes based on the value of resultant, which is again dependent on the value of frictional force and normal reaction. So, This is the angle of static friction, and it helps us in analyzing the object under limiting static friction. Now, we'll move on to the third concept, the angle of repose. We can understand it better through a simple experiment. Let us say we have a TV on an wooden table. We have done special modifications on the wooden floor. That is, it is hinged at one point and it can be made into an inclined floor. This wooden plane will make an angle theta with the actual floor. When you go on rising this wooden floor, the angle theta will also increase. We reach a point where if you increase the angle of the plane, the TV will start to slide on the inclined plane. This is the angle of the wooden floor at the point of impending motion, and we call this as angle of repose. This is the angle of repose. Now, let us move on to the last term, the cone of friction. We consider the same example of TV, but this time it is on a horizontal plane. We learned in the previous concepts that the resultant of the limiting static friction and the normal reaction can reach the maximum value, and the angle at the point is phi s max, the angle of static friction. So, the angle phi s max can be reached at both the ends of the object. The resultant has an inward angle of 2 phi s. If the resultant is beyond the line OA or the line OB, the object will start to move. Therefore, for the object to be in the state of rest, the resultant has to be within this triangle AOB. This is in 2 dimension. But if we consider the object in a 3D plane, then we can construct a cone of length OA around the normal reaction axis. This cone is called the cone of friction. It tells us about the resultant and the point of impending motion. So, we have come to the end of this very important video. Understand each terms discussed in this video because these are the basic concepts that helps you to solve many complex problems, and it is one of the probable questions in your examination. To sum up, we first learnt about the concept of coefficient of friction, and then we learnt about the angle of friction. After that, we moved on to the angle of repose, and finally, we learnt about the cone of friction. This brings us to the end of concepts in this chapter. Up next, we'll solve few important numerical problems. See you there.